All right, I think we're about to get started. Please take a seat and make sure that the usual announcements, there's nothing blocking the aisles, no cables, no bags, nothing else, so nobody trips over and we can actually empty the room if we have to in an emergency. With that, I would like to introduce Ilya. He's the director for pen testing at Active, and most of you probably know him. He's been looking at the Xorg code, the X Windows system code, and things he found there. And I'm sure it's going to be very interesting. Had a few chats with him before. Yeah, please give him a warm welcome, and let's hear what he has to say about it.
Thank you. So my talk's going to be on X security, and the subtitle is "It's Worse Than It Looks," pun intended. So who am I? As I was just introduced, I work for a company called Active. I am their director of penetration testing. I run pen tests and lead pen tests and do code reviews and basically break stuff for fun and profit. In short, my talk is going to be, I'm going to do a small intro. I'm going to talk about security of X clients. I'm going to talk about security of X servers. And then I'll have a sort of slide at the end where I'll sort of be like, well, how bad is it really, and is there anything we can do about this? So what does this talk about? It's the implementation of Xorg parsers, specifically how all the data comes in on either the client or server, how bad or how good that is. And then I'll also say something about specific trust boundaries and entry points into either the X client and the X server. And I'll show some bugs and trends of bugs that sort of show up on both the client and the server side. And then near the end, I'll sort of have this slide where I say, well, how bad is it? What can we do about it? Specifically, what is this talk not about? It's not about the network operations side, right? We've known for a long time, yes, if you have networked X and you don't tunnel it over SSH, people can sniff, they can do key logging, all that kind of stuff. This is well-known stuff, so I'm not going to cover that. I'm going to talk about implementation and not the network side of things. As far as the introduction goes, I actually started looking at this stuff about a year and a week ago. Right before the Congress last year, I decided to download the X11 client code and started I looked for a receive function, and then basically from there started looking at some of the parsing. The client code was fairly easy to grasp and sort of find the entry points. Within a week, I run through all of it and sort of weeded out all the low-hanging fruits. Reported about 80 bugs. They all got fixed, well, almost all of them, but all the X bugs themselves got fixed. And then sort of as of May, June this year, I moved on to the server. And initially I was like, oh, well, you know, it'll take me about a week. And it turns out it took me much longer. I haven't really finished yet. Server is enormous. There's so many extensions. I have not finished yet. Thus far, I have reported 120 bugs about 25 hours ago. So the server bugs have not been fixed yet. But before we talk about server, let's move on to the client. Some easy observations about X, in case you didn't know yet, is that it's a client-server protocol to be used for the GUI, and pretty much anything that's Unix and has a GUI has X. Even on macOS, I guess Apple doesn't ship X quartz anymore, but most people still install it. The X server is networked or can be networked. Can be over TCP or IPC. It's a binary protocol. The client basically parses, or the client parsing becomes interesting when your client runs with high privileges. So if you have an SUID binary, for example, that's interesting attack surface from the X client perspective. And the reason why is because if you have a privileged SUID application that uses X, you can basically say, hey, connect to this malicious X server, and it'll go there, and it'll fetch all of this network data, which you can spoof and send in malicious data. And it turns out getting it to crash is really, really easy. So in case you don't know what X looks like, kind of sort of looks like this, or it looked like this 30 years ago. So the X client libraries are basically the attack surface. So if you look at this thing, I don't have a pointer, but so this xlib thingy here, that's the attack surface, right? So I spent a week looking at all the libraries that sort of fit within xlib. there's XCB, and people have kept asking me, have you looked at XCB yet? Have you looked there yet? I have not looked at XCB yet. It's on my to-do list, but so are 100,000 other X-related things. So I'll get to it at some point, but I have not looked at XCD yet. Going back to XLib, what I can tell you is that things are unbelievably bad. It's all binary protocol parser C. It's all code that's written in the 80s. The server the library was written in 1984 with the idea that the server is trusted. And so there was very, very little validation done. Yeah, as I said, in a week, something like 75 bugs or something. So it was instantly obvious that that code was never written with a trust boundary in mind. And so with that, since the bugs have been fixed, I can now talk about or show an example of some of these bugs. So I've got a set of examples in here. I'm not going to run through all of them, but I'll sort of run over the first 3 or 4, and then I'll sort of skip through the rest of this code, because spending entire hours looking at code is kind of boring, at least when you have an audience in front of you. But just to give you an idea of how bad it was, these are things that sort of, the first hour you start looking at this code, all this stuff just sort of falls out, right? So basically, the first thing I did is I downloaded all the XLib code, and I just grepped for _x reply. And right there, that's all your entry points. And so this rep thing is basically data you get back from the server, and then this x32 basically reads more data from the server, and it takes this length value, which the server gives to the client, and the client just blindly trusts it. And so the client can say, hey, I've got 4 gigabytes of data for you. And this pixel buffer is not, it's much smaller. So these are trivial memory corruption bugs, 2 of them. Another very trivial bug is basically, you do X reply data comes back from the server, and there's basically a memory allocation done based on this data. Trivial textbook integer overflow right there. Another example is this data came from X reply, and then one of the elements are used as an index into an array without any kind of validation. Trivial unbound index bug, textbook example. Here's another one where, so this doesn't use _x reply, but uses x get window property, which is basically a wrapper around _x reply. Gets back a number of items from the server, and basically just does a mem copy on those items. It does link checking, but it turns out these links have nothing to do with the length of the items. So it's a pretty standard memory corruption bug. There's piles and piles. I've got like 20 or so in here. So if you download the slides later and you want to look at this, you can see just how bad it really was. But just to give you a grasp of the overall bugs I found, there's been a set of these bugs that were found. Oops. Okay. And that's just that. I think that's 20. So there's like 4 times that many that were found. So all the discovered bugs have been fixed. It was really cool when I submitted a bug. So usually when you submit bugs, you never quite know what you're going to get. Sometimes people will ignore you. Sometimes people get very defensive. Sometimes people will be lazy, and it'll take 2 years to fix a single bug. I was very pleasantly surprised when I submitted these bugs to security at xorg. Within a couple hours, I got a reply back from one of their developers, a guy named Alan Cooper Smith. This guy needs a shout out. This guy's fantastic. He fixed all the bugs within a 3-month period, 80 bugs within a 3-month period. Has a very deep understanding of X, which not too surprising because he's one of their developers. But the good thing was, usually when you report bugs, people they might not understand it. They might not have the security knowledge, and so you have to sort of hold their hand, and they'll say, "Oh, that's not a bug," and you have to go back and say, "Actually, it is because of so and so and so." Didn't happen a single time. Every single bug I send him, he instantly understood and saw what the consequences could be. There was no pushback, no hand-holding. It was fantastic. Alan worked tirelessly. I mean, to do this kind of looking over and understanding 80 bugs, and then making fixes for those 80 bugs, then reviewing the diffs, and then doing all the testing within a 3-month period is pretty, I mean, that's like Superman, right? So that's really, really good. Yes, exactly, yes. And on top of that, I also had some email conversations with him regarding the bugs that I found. And so Alan had some interesting comments. This one is actually a serious one, and the next one are sort of more funny notes. I may not read the entire thing, but he sort of starts off saying, well, and this is where he shows how good he grasps that there's a trust boundary and a security element to the X client libs. He says, well, I don't know how many setuid X, and I never mentioned setuid to him, so he says, I don't know how many setuid X clients still exist these days. Is Xterm still around, so and so and so, but since we know there's more X clients than we can keep track of, especially ones homegrown apps in various companies and so forth, we have to assume there are still some. It would be good to put a reminder in our security advisory. The best practice is to separate out parts of the application that require elevated privileges from the GUI to avoid such issues. GTK requires this, but not all toolkits do. And I'll get into that last part in a little bit. So these are other observations he made. These are less serious, but kind of funny. And he goes like, shoot me now, and then shoot this developer for not fixing XKB, and then shoot anybody else who touches XKB because it'll be too late for them too. And he goes like, well, after my analysis of these first batch of 80 bugs, I got so tired, my head started spinning trying to figure these things out. And then one of his comments on one of the bugs were, if you have a window shape of 2 to the 30 second rectangles, then what the hell are you doing? And there was an endless stream of these sort of kind of funny comments on these bugs where X allows for these very liberal things that no one would ever do. But then it turns out if you try to do them, X is going to blow up anyway. But they don't stop it. And then what was really cool is when this bug got fixed, there was an LWN thread about it, and it was sort of the standard LWN trolling. But among the comments, there was one that I thought was just perfect. One of the original X developers commented, and he said, and I just want to sort of read this, the first part of it, because it really sort of captures how bad the state of X still is today. He says, well, all I can say is it was 1984, and it was a very, very different world. We're talking over 25 years ago. Many LWN readers weren't born then. There weren't many bad guys out there. I remember the Moore's worm hitting, which was way beyond, was after 84, when I was working on X11 protocol bindings, and Kevin Minnick had just reared his head a year or two before. Some of the bugs I clearly wrote in that period, and others copied my mistakes. Others just could, and clearly made mistakes of their own. Says other bugs just couldn't happen in the practice of the machine in that era. So if you have 2 megabyte microvacs, and so some of the bugs I submitted was like, well, you have this 4 gigabyte text file, and if you parse that, then the thing blows up, which today is very easy to do. 30 years ago, it was impossible. The sort of fallout of when these bugs got fixed was interesting because, so another shout out is to Debian. So what happens is when you submit bugs to X, they say, well, we'll go fix them, and then they want to have these 2 weeks, so after they have all their patches in their Git repository, they have this 2-week embargo where they go to all the vendors and say, hey, listen, here's our fixes, we'll keep it silent for 2 weeks, and you get 2 weeks to get your shit together, and then we'll just release the whole thing. That works pretty well when you have 1 or 2 bugs. When you have 80 bugs, not so much. Debian was the only one who, within the 2-week time frame, merged in 104 patches, all within a 2-week embargo, full reason advisory on the day the embargo expired. No one else managed to do this. And the guy mostly responsible on the Debian security time, I hope I'm pronouncing his name correctly, Moritz Mühlenhof, deserves a lot of the credit for this. So I think we should all, yes. So this is all very nice, but nobody really uses raw X anymore. When you write a GUI program that's going to work in X, nobody uses XLib, right? Everybody uses these frameworks that are built on top, right? GTK, KDE, Qt, Motive, there's a bunch of these, right? So I start looking at some of these and see, is it better, is it worse? Start looking at KDE and Qt, and their crappiness is bang on par with XLib. Trivial bugs, like this one, where basically you have an array of 5 elements, and then you just take arbitrary data back from the network and just start copying it in until you run to the end of the array of data you got back without validating that if it's bigger than 5, you should have bailed out. And they didn't, and so it's a standard stack smash. This is Qt init code. So any Qt application is vulnerable to this, where basically if you give it an app name in a certain circumstance, they'll take app app name global pointer and assign it your argv pointer, which comes from main, and then the Qt cleanup code will assume that it's been newed, C++ newed, and it'll do a delete over a pointer that's argv. Clearly, that's going to blow up. And there were a bunch of these bugs, right? So I reported these to the Qt guys, and their response was just night and day difference compared to the X guys. And so the quote from the X developer earlier on about the setuid and all these frameworks not having setuid checks and so forth is dead on. So Qt doesn't really have those setuid checks. And so when I reported the bugs, the Qt security guys did not agree with me at all. They emailed back and say, well, KDE has precisely one setuid application KDE check pass. For this very reason, I suspect someone running Qt applications would fall into a huge number of problems, the most obvious of one being a malicious styles that would allow them to trivially execute code. So basically I sent them bugs, and their reply was, oh, here's more Ode. Not the response I was looking for. So I respond back and saying, well, you're a library, you shouldn't dictate policy. And there are, in fact, more KDE SUID binaries. Specifically mentions KPPP because I found bugs in there in the past, and I know it's still around, and I know it's still at least being maintained. And so on top of that, I quenched snow on the styles thing because I really want to know if there's actually executable code in there. Just to be sure, they gave me a 0-day. So they basically mail back and say, well, that would be a security hole in those applications. Rather than Qt, there are many ways people could abuse library to create unsafe applications. And then I go, do styles contain executable code? And they say, yes, they do. And then I ask them, well, is KP no longer run as setuid? And then this is beautiful, right? They quote from the frequently asked questions from KPPP, but they cut off the quote. It's an incomplete quote. So the quote they give me is, there's no need for the setuid bit if you know a bit about Unix system administration. Simply create a modem group, add all users that you want to give access to the modem group, to that group, and make the modem device read-writable for that group. Not that hard, but not all distributions come pre-configured like this. There are, in fact, still a bunch that have KP setuid instead of doing this. So anyway, that's their partial quote, and they say, then they sort of speculate, I doubt any modern distribution would install setuid. In fact, most are extremely careful about this, yada, 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 yada. And then, so I look up the exact quote, and this thing is true, but it goes on to say, the KPP team has lately done a lot of work to make KP setuid safe, but it is up to you to decide if any way you install it. But we put in a lot of work to make it setuid safe, which means they would be okay with having it setuid. And in fact, I looked at Ubuntu, and if you install KP on Ubuntu, by default, it comes setuid root. But the more important issue is that their library code, right? As long as you use their APIs correctly, they should allow for SUIDs to call them. Or either that, so what's really bothering me is that they're sitting on the fence because it's easy, right? They're saying you shouldn't do this, but they're not enforcing anything, right? So either defend it and shut up, or do a setuid check and exit, right? They're not doing either, they're just sort of sitting there and saying, oh, not our problem. So none of the bugs are fixed. So the bugs I just gave you earlier, those 2 Qt bugs, those are 0-day. But the really cool part was I got their okay to give you the 0-day. I asked them if they consider a security, since they're not considering a security issue, can I talk about this publicly? And they go like, yes, sure, go right ahead. So here you go, 2 0-days. So that was sort of the Qt part. I don't know how well you guys know the Unix environment, but in Unix you have this sort of standard LD preload, which is you can sort of change which libraries you load when you start an application. That's been made setuid safe. In the 80s and early 90s, there were problems with that for setuids. This has long been made setuid safe. But of course, those frameworks, KDE, Qt, GNOME, they must have their own LD preload equivalent, right? KDE has Qt has something called Qt plugin path, and GNOME has something called GTK modules. Neither of these are setuid safe. At least the GTK modules things is somewhat known, and the GTK people seem to know what they're doing, and they're aware of this problem. And so what they did is, or what they're saying, is that they don't allow setuid GTK applications, and they have a website clearly explaining it. I'm not going to read all this. If you download the slides, you can read the whole thing, or you can go to their website. It's gtk.org/setuid.html. It explains the whole thing. It's kind of dry and boring, but the gist of it is this quote, right? And if you read the whole thing, it's really beautiful. It's well thought out. It's saying whoever wrote that policy, it clearly knows what he's doing on the security side of things. And so the quote in there is basically, or sort of the money shot is, security of GTK Plus requires the security of XLib. The GTK Plus team is not prepared to make that guarantee. That's a pretty good thing, right? If I wouldn't make it, I've seen their code, I wouldn't make that guarantee either. But is it really true? So I go and look at their GTK main, and it has right before they do the check SetUID, they have a comment explaining the whole thing, and they say, well, this check is there to see if it's SetUID or SGID at the current time. And so if it is, then we don't allow GTK to be initialized and we exit. And then they go on to say, but this is only meant to be a mild check. We only error out if we can prove the program is doing something really wrong, not if they're probably doing something wrong. For this reason, we don't use isset UGID on BSD or PRCTL get dumpable on Linux, which is the proper way to do it. They didn't do that, right? So what does that mean? It means you can still have suite binders on GTK Plus. You just can only initialize GTK after you did a priv drop. So that means you have to, when you write your program, you have to first acquire all the privileged resources you want, drop your privileges, and then run GTK, which means if you were have a bug in it, you couldn't immediately escalate to root, but whatever privileges are still there, secrets in memory, file descriptors, IPC handles, all that kind of stuff, you would still get to steal all of that if you get to exploit a bug. So GTK still kind of, sort of allows for SetUID applications. It just becomes like a tad bit more difficult. Games are a great example for this, for example, right? So there's a bunch of known SetUID games, and what they do is they share a high-score database file. And so the reason they need privs is to open a read-write handle to that high-score database file. Once they have that handle, they drop all privileges. And so now let's say there's a bug we could exploit, or we would use the GTK modules, right? All of a sudden, we have code executing inside that SetUID high-score file, and the privileged resource that we want is that handle to the high-score file, right? Now let's say, for example, there's a secondary bug in the parsing of the high-score database. Because the high-score database is not considered a trust boundary because it's a trusted resource, chances are that parser is going to be really weak. So let's say there's a bug in there, we know how to exploit it. Since we have that read-write handle to the high-score file, we write our shell code and whatnot properly into the high-score file, and then when any user plays that game, they'll get owned by trying to read the high-score file, right? This is just sort of a potential case where this can come up and be a problem. By far one of the most common bugs I saw when using XLib. So I said earlier that xGetWindow property is basically just a wraparound underscore xReply, which basically is a wraparound receive, so it just takes raw bits from the network. This is the most common bug that I found when I was looking through people using it. Basically, the way xGetWindow property works is that you hand it a pointer to a pointer, and when a thing succeeds, it fills in that pointer with something to locate it, and then when you're done, you call free on that pointer. But when xGetWindow property fails, for example, the malloc fails, that pointer never gets initialized to 0. So if you don't check the return value, you always assume that the thing succeeds. You're all of a sudden end up using a pointer that was never initialized, right? And so you end up freeing arbitrary stack memory, which is bad. The really good part is I sort of mentioned to Alan, I said, hey, this isn't really a problem, but it's a common pattern I saw. And he says, oh, we forgot to initialize this thing on failure. So he goes and puts in a fix, and it's just no longer. This was a problem for 30 years in usage, but it was never an implementation problem, right? And so Alan went in anyway and said, well, we're going to fix it anyway. So after 30 years, this problem is just gone. It's never going to happen again. And basically, so when I said that, for example, xGetWindow property is a wraparound xReply. These are sort of the standard. All of these functions are sort of X client wrappers, and all of these just basically take bits from the network and sort of hand them off to a bunch of parsers. So these are good things. If you're looking for X client bugs, just grep for these functions, and those are all your entry points. And then there's a bunch of xGetWindow property wrappers. So these are basically all just also take a bunch of bits from the network and sort of hand them off to parsers. And that's all I did. I grep for these functions and sort of started reading what they did with the data that came back. And in a week, there were about 80 bugs. Conceptually, there's basically, so the idea is that people, so one of the responses was on LWM, for example, when the advisory came out, was that, oh, well, this isn't really a problem because there's no X-SUID applications around. Turns out it isn't true. You take any given standard Linux distribution or whatnot and just do a standard grep for SUID apps. Half the time, you're going to find at least one or two applications that are set UID or set GID that'll use X in some way. And you can point them to a malicious X server, and getting them to crash is going to be really, really easy. But generally, conceptually, there's a set of standard X SUID applications still around. Configuration tools like KBP, games like a bunch of known games, and screen locking tools, XLock, XLock More, X-Screensaver, so forth. They do early priv dropping, but they still have some interesting resources in memory. The good thing is that, I mean, in the late 90s, most of these things would have still ran as root through their entire lifetime. Nowadays, they'll do sort of the right thing, or as right as they can. They'll get all their privileged resources they need and then drop privileges, which means if you have a bug in there, doing a pivot to root is not going to be easy or not going to be instant, but you will still have access to all the privileged resources that those programs hold. So this is kind of my client summary. Xlib and SIDs is a bad idea. People think there aren't any around. There's more than you think. Just take whatever Linux box you have, do a scan. There's a 50% chance you'll have at least one or two SID binaries that use Xlib. So it happens more often than you think. GTK Plus kind of sort of still allows SUIDs. They're not, the case isn't as clear as they make it out to be. And the last part is that, and this thing was really more a symptom of a bigger problem. When you read applications that use Xlib, there's an enormous sloppiness when they use the APIs. I didn't really zoom into it that much, but if you have some free time, just go download a bunch of apps that use Xlib and just start looking at the way to use the Xlib APIs. Half the time they'll miss syscalls, or they're misinterpreted, or they'll do all sorts of very sloppy things that, are just sort of, if you were a developer in the 80s or maybe even 90s, that was okay. Today, not so much. But then again, most of those apps are probably written in the 80s or 90s. So that was the client side. So that stuff I did in December last year, and I did a bunch of presentations on the client stuff. The server stuff is much newer. I've been reviewing it ongoing, on or off in the weekends and when I have time, since May or June. I'd say June, July, August is when I did most of the time, and then there was sporadically a few days here and there, and then yesterday. Not finished. There's a lot of code. I'm lazy, and then I don't know if you guys know what GLX is. I'll zoom that later. But GLX are basically the OpenGL bindings for X Window system. GLX is horrible. It's terrible. It's terrible. It's about 8,000 lines of sheer terror. It has 6 or 7. No, seriously. It has about 6 or 7 callback tables, and each and any table is anywhere in size of 74 to 408. There are several thousand callbacks there, basically. All of them are attack surface. All of it takes data from X, and most of them are broken beyond repair. It's really horrible. So just trying to sort of keep reading GLX code is horrible. It's a terrible demotivator. It's one of these things where, when you read code and you find a bug and you copy paste into a text file because you want to do a formal write-up. This is one of those rare occasions where you get tennis elbow from old copy pasting. So you remember this network architecture I showed earlier? Total lie. X doesn't look like that anymore. It looked like this in 1984. It was designed to be this way. Doesn't look like it anymore. It hasn't looked like it for at least 15 years. There's a talk. So there's a guy named Daniel Stone who I referred to earlier in one of the comments by Alan. He's one, or used to be one of the X developers. He moved on and sort of is now a fairly famous Wayland developer. So Wayland's sort of the next version, or sort of the replacement for X that's in the works. He did a talk earlier this year at some Linux conference in Australia. I have a link there. If you have some free time, or take a picture from that link or something, you should watch it. It's very, very informative. He sort of goes like, yeah, X doesn't look like this at all. Actually, it looks more like this. which is fairly more complex. And so I don't want to zoom into this too much, but this is basically your client stuff, and this is still your server. But then there's a part in kernel, and there's a part where you get direct memory access, and there's a part where you get shared memory, and then there's basically you get memory mapped I/O and those kind of things. And so when I say server in my slides, technically this is just a server, but when I say server, I refer to sort of all of this, right? So it's a bit wider than just the X server, but it's sort of all the things the client talks to, I consider the server. So let's take a step back from that and sort of go back to the initial, and let's start with the beginning, which is when they designed this thing in 1984, the first thing they did is they made a core protocol, right? They said, these are all things we're going to need. The core protocol is straight C code, but when you read it, it's one of these things where it feels very object-oriented C code. And this was written in the early 90s. If it was written 10 years later in the early 90s, it would have probably been C++ code. Not saying it's better or worse, but it would have probably just been, because of the way they designed their code, it would have probably been C++. The code is fairly good from a security perspective. The core protocol is actually not bad. But I think I don't think it was initially like that. I think over the years, people have found bugs, and so you can see the things where they patched integer overflows, right? That concept, a buddy of mine calls it a polished turd. But X is certainly, the X core protocol is a good example of that. So the core protocol itself has very few low-hanging fruits. That thing has actually been looked at throughout the last 30 years. So what does the core protocol more or less looks like? If you happen to have the code, there's a file called dispatch.c which contains the main dispatch loop, where connections come into the X server from a client, and then initially all the client can do is only call two procedures. One is to initialize the connection, and one is to establish the connection. The initial connection basically just does a set of very standard things like, hey, this is the byte order. Because X can do both little and big endian, you have to give it a byte order, and then X will take care of all the endians for you behind your back. That's what the initial connection does, and I'll get back to that in a minute. The other thing you have to sort of establish, after you do that, you have to establish the connection, and that basically means authorization. Depending on the way you set up your X server, that can mean very little, or it can mean a lot, depending on the way you configured it. Once you get past initial and established connection, clients can now talk the full core protocol to X, which are about 80 or 90 procedures. Requests are initially limited to 64K. There's a big request extension which everybody uses. It has been using for a very long time, which allows up to 60 megabytes per request. But initially, 30 years ago, 64K ought to be enough for everyone. Turns out it wasn't. When a client sends a request to the server, the content sort of comes into this fairly standard type length value header thing. Any procedure you call has its sort of own request, but every request starts with the same basic three types, which is the X request header type thing, which is the first 8 bits, which is the type, the next 8 bits, which is called data, and then the next 16 bits, which is the length, right? And because that length is 16-bit, initially you could only have 64K. When you have the big request, they sort of mount this 32-bit length on top, but we won't get into that. So what does this mean is that when you send something over that's shorter than these 4 bytes, it will automatically get rejected. It will never make it to X. X will just be like, this is too short, and throws it away. Anything that comes into X that gets accepted is going to be at least 4 bytes long. The type basically gets validated in the sense that 0 to 127 is core X protocol. Anything above that are X extensions. And then basically, that basically says, like a type 132 would be extension XYZ. And then that extension would need its own subtype. And the way that subtype is done, there's no standard way. The extensions get to pick how to do their subtype. It just turns out that most extensions will just take this data thing and use that as their subtype. But they don't have to. They can do it any way they want to. Right, so once you get there, and the clients get called any procedures they want, there's 2 callback tables, actually, tables.c, not surprisingly. One's called proc vector, and one's called swap proc vector, and they're essentially exactly the same. Proc vector contains all the 80 or 90 procedures you can call. And a swap proc vector is the exact same thing, but it does swapping for endianness. And then once it did all the swapping, it goes and calls into proc vector. And then the core protocol basically does what the core protocol is. I'm not going to get too much into detail here, but there's a bunch of really, really boring and old specs about this. And they basically allow you to create, destroy, and query windows and atoms and properties and images and text and strings and extensions and all sorts of weird little things. That's, in a nutshell, the X core protocol. So now that we've sort of covered the core protocol, let's move on to extensions. Extensions are basically, so X11 is really old, it's 30 years old, it's very outdated, it's completely broken, and extensions are the way to sort of keep it on life support. And so the way it still works, the reason it still works today to the point where it's not super slow is because we have, on any given X installation today, you'll have anywhere between 20 and 30 extensions. And without those extensions, you wouldn't want to use it, it's way too fucking slow. So there's extensions for input devices and output devices and shared memory and using OpenGL and using direct rendering and having a bunch of drivers not in userland but having them actually in kernel and all that kind of stuff. And the way you do that, the way you add an extension is by an X API called add extension. And you go there and say, well, this is the name of my extension. This is my main processing code. This is my main processing code again, but which does all endianness swapping. And then, that close down prog is not defined half the time. And then minor opcode is basically this thing where, because as I just said, that the extensions get to sort of pick how they want to do their own subtypes, that minor opcode prog gets to decide what the subtype is. The other thing about extensions is I sort of want to say about it's a little thing because there's a lot of potential for bugs here, but this is sort of quite complicated stuff. So you can have all these sorts of weird handles in extensions, and then they sort of it feels a little bit like kernel land, where you have a handle to a data structure which is of some type. And so extensions, you can have all these sort of different types of resources, where you can have an XID or a handle to a different type of resource. And there's a set of, I think, 15 or 20 standard resource types that X has, but any extension can make its own resource by calling create new resource type. A create new resource type basically takes two arguments. One is the name, saying, hey, this is what my resource is called, resource XYZ. And then two is a rundown function, a delete function, where basically when you clean up this resource, what are all the things, it'll describe or it'll do all the things that you have to do to get rid of the resource. And that because you get this kind of you can have this very kind of, depending on what kind of resource you implement, you can have this very complicated delete logic. I found one bug in there so far, but this is not trivial. This is really complex stuff where you sort of have to steer X into one way, have this sort of weird things where, if this option said, but this one isn't, then three guys call this, but this never happened. Then this one bit gets said, otherwise it doesn't, and then if it gets said in the wrong way, then when you get delete logic, something would get freed twice, or it wouldn't get freed or something like that. So you get this very weird delete logic. I suspect there's going to be a pile more. But because I was looking for low-hanging fruits, I didn't really look here. But once we get rid of all low-hanging fruits in the X server, which is going to take a long time, this should be the next step. I think there's a bunch of complicated bugs just waiting to be found in resource deletion. So server extensions. If you look at the code, I sort of just grepped for add extension, and these are basically all the files that add a bunch of extensions in X, right? So that's a pretty big list. Some of them are outdated, some of them are only used in certain circumstances, but on any given recent machine that uses Xorg, you could have anywhere between 20 and 30 extensions. If you want to see what your extensions look like, I wrote this very, very trivial piece of code. If you run that, it'll tell you exactly what all your extensions are. And if you don't want to write my code because you don't trust me, basically there's an X API called xlist extensions. You just call that thing, and if you don't know how to use it, just read the man page. It's very easy to use, and it's very easy to query all the extensions that your X server runs. Clearly, this stuff is prime attack surface, right? The extensions is where all the cool stuff is. Because as I mentioned before, the core protocol has been audited to death already. There's very few low-hanging fruits. Nobody's ever looked at the extensions. The extensions is just streams and streams of bugs, right? For the past couple of months, I've found 120 there, and I'm not close to done. I reviewed a lot of the extensions, but not all of them yet. Yeah, basically, I'm still to this very day, I'm stuck on GLX. It's sort of this never-ending stream of crap. It's humongous, it's horrible. Every parsing routine I've seen so far has been broken beyond repair. Once I get out of this hellhole that's called GLX, I'll be able to look at other extensions. But I'd like to believe I've reviewed a fair amount of them by now. So now that I've sort of covered that, so what does a general procedure look like in an extension that an X client will call into, right? And it's basically, I'm sorry, my slides kind of suck because I wrote them on a Mac on a different version of PowerPoint, then I send them to myself, and this is my Windows machine, and of course the layout's kind of screwy. Let me see if I can't fix that. This is better. So what does a general procedure look like? It's basically 4 or 5 lines of code. That is sort of the standard template, right? So this would be your proc test, and you get this sort of standard client structure back. And what you do is you call this macro called request. And request knows there's something called client. And what it does is it creates it creates a variable on the stack called stuff. Yeah, seriously, it's called stuff. Of this data type, which is the structure that defines the request that's going to come in that's very specific to my procedure. And that's what request does, right? It basically declares xtest request stuff equal client user buffer semicolon. And that basically defines all the stuff behind your back. And then request size match basically says, yeah, this is the size of the thing. Make sure that it's validated. And if it's not, just bail out. So this does length validation behind your back. Once you have that in place, basically what you do is you call this, you basically just use this stuff variable. And then I just made up a random function called use request data. But every time you touch stuff, that's data that comes from the network, from a potentially untrusted X client. So there's several size macros. Request size match is basically you give it a type, and it means that the size of your request has to match exactly the size of the struct. If the size is off for some reason, bails out. Request at least size basically means if the data you send me has to be at least as big as the structure or bigger. And then the last one is request fixed size type length. And basically what that means is it's got to be the data you send me has got to be exactly the length of the type plus the length that was given. What's interesting about request size fixed is that it has an implicit integer overflow. This length thingy right here, if it's user controlled, then you can make it about 4 gigabytes big. It'll overflow internally. And there's really no way to fix it because you can't bail out of it. It's a macro, it's not a function, right? But if you use these macros correctly, that's how you prevent trivial out-of-bound read and writes in any procedure for extensions, and even the core protocol. So now that we know that, let's sort of go over the standard types of bugs. So because the 120 bugs I found, I reported them about 25 and a half hours ago by now. But because clearly they haven't been fixed yet, I decided not to talk about specific bugs yet because I don't want to drop 0 day, unless people tell me I can. So what I'm going to do is I'm going to tell you about the general types of bugs I found. And that sort of because I've seen enough of the code that I kind of have an idea what the trends are amongst all of the extensions in the core protocol. This is obviously a very common one. Certainly not X specific, but yeah, if you do memory allocations and if you check the return value, you might crash on a null pointer reference if you're out of memory. X has piles of these bugs. Obviously, integer overflows, right? Big one. Certainly, when you're parsing binary protocols, you're going to have piles and piles of integer overflows. And there's 3 cases in X sort of where this happens. One is when you parse large config files like font files and so forth. There have been a bunch of these where you have really large config files with, let's say, 4 billion entries or something. Yeah, that's probably going to overflow. When parsing protocol data, obviously, right? it's either going to be out-of-bound reads where you bypass some kind of length validation, or memory corruption when you have an integer overflow when you're doing buffer length calculation. Obviously, same thing happens in malloc wrappers. And then when you have the implicit use of request size fixed, that can have integer overflows too. This is sort of not an X-specific bug, but it's sort of this cute little thing where if you do heap allocations in C, you have malloc, realloc, calloc, and free. And realloc has this really, really cute corner case where if you give it a val pointer and a length of 0, a realloc sort of short circuits. It says, I'm just going to free the data and hand back a null pointer. That's by design. All the man pages say it has to be that way. But there's a large number of C developers that don't quite know about that corner case. Including some of the X developers, because there's a bunch of these bugs within X. Obviously, unvalidated length field indexes. I actually did have some examples of that in the client side. The server side is not much better. They have a bunch of these too. Out-of-bound reads, right? You take a structure, you don't validate the length, you just read out a bunch of elements. Yeah, that might be an out-of-bound read. The other thing is byte order bugs. What I said earlier is that the X server can take care of a byte order for you. It does that, and the way it does that is because they have the swap vector. So they'll have, before they call a real function, they call the swapped function, which does all the swapping. Now, the real functions generally are written, at least the recent ones, are written by fairly competent people. They'll make mistakes, but they'll at least know something is. They'll at least know they'll have to do some kind of bound checking or some kind of integer overflow checking. But when people write the swapping code, they don't, because it's this tiny little piece of code that does fix-ups and nobody really cares, and they just want to be done with them. So most of the swapping code is horrible. They never do bound checks, and because they actually swap bytes. They're not just out-of-bound reads, they're out-of-bound writes, because they swap pieces of memory outside of a buffer, so you get all these sort of weird memory corruption bugs when people do these byte order fix-ups. Yeah, okay. Obviously, memory leaks, I saw it, not X-specific, but X had a bunch of these where they'll do a bunch of mallocs or stridups or so forth. And then there will be some corner case, and they'll forget to free the data. So this is pretty much as far as I've come. I had hoped to have gotten further. There is an unbelievable amount of code in there. Again, fucking GLX. So the rest of the slides, I had hoped to sort of gotten there, but I can give you some general pointers as to, I read some specs, and I know a little bit about these things, and there's a tiny bit at the end where I know a little bit because I spent last night reading up on this stuff, but most of the rest sort of is more hand-wavy. Yeah, there's X obviously has a bunch of drivers, font drivers, drawable drivers, so forth, blah, 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 blah. I wanted to look at server-side display drivers, haven't gotten to them yet. This is interesting stuff, but this is pre-direct rendering infrastructure. These are sort of legacy drivers, I guess. The font drivers I actually did look at because you can get to them through the core protocol, and so I looked at a bunch of the font drivers. Font drivers are horrible, terrible. This is old code written in the 80s. Not used anymore, but it's still there. Nobody uses a font server anymore. But the way it works is that your X server has a font client in it, and you can go there and say, hey, connect to this font server, and it'll go out and connect to your malicious font server. And the font parser in that client is just terrible. Piles and piles of bugs. Yeah, OpenGL drivers, haven't looked at them yet. It's sort of my next step, because I look at GLX, I have to eventually look at OpenGL too. I suspect it's going to be an enormous shit show. Based on GLX, it's got to be terrible. And it's one of these things where GLX calls into all these APIs that the drivers expose. And it's going to be long and tedious work mapping sort of the thing that GLX talks into these drivers. Eventually I'll get to this, but I haven't gotten to that part yet. Yeah, Xserver has a bunch of dependencies on libraries. Initially when I started this thing, I figured, oh, Xserver, that must be self-contained. It turns out it's not. All of a sudden you see all these references to Pixman and so forth, and it turns out that's some third-party library. So I had to go and download those libraries and include them in my auditing as well. So there are some bugs in libraries too, but since they're not part of X, I'm not covering that here. The last bit that I want to sort of cover, hopefully I can do it in 2 minutes, is DRI, which is called direct rendering infrastructure. This is the thing that makes X really fast, actually. This is also the thing that makes X not network transparent, right? X used to be network transparent, has been a long time. large part due to DRI. What DRI does is basically says, well, yes, you'll have this GPU and all these cool things, and what we're going to do is we're going to give you the client direct access to the hardware, and we'll have some driver stuff in the kernel that manages the stuff for you. And so you get all this memory mapped I/O stuff. And the way that works is you have this direct rendering manager, and that thing lives in kernel. And this kind of looks like this. So you have this X11, and then X server will sort of do it for you, but you can sort of make your own, and then sort of you get access to direct GPU stuff, but then you'll have this DRM, direct rendering manager that you'll see in kernel. And every time I see DRM, it screws me up, because when I see DRM, I think digital rights management, and then I go like, no, it's not. It's direct rendering manager. Anyway, so last night I spent some time looking at the direct rendering manager in the Linux kernel, which is basically implemented in drivers, GPU, DRM, DRV, and that's basically a manager in this framework. And so when you make your own kernel drivers, they sort of plug in below the DRM thingy. DRM drivers expose ioctl interfaces, and basically they can have their own ioctls, and then they can also expose ioctls from their drivers. In Linux, so ioctls in BSD originally have some structure to them. You can say it's input, output, and you say the length. Initially, when Linux had ioctls, they regarded all of that structure. They said, ioctls just a number. We don't care what it means. We don't care. There's no underlying stuff. It's just a number. The DRM ioctls sort of mount the BSD ioctls of Linux ioctls, whereas their ioctl numbers actually do have bits that contain this is input, this is output, this is a length field. And this is and they add a little bit more on top of that. So the way it works is when you create a driver, you use these macros, and then you say, this is the name of my, this is the ioctl of my thing, this is my callback for this ioctl, and then a bunch of flags here. And those flags basically validate where it says, well, if the flag says root only, then if you have to be capsys admin. If it says DRM auth, it means you have to be a client that has to be allowed to render stuff, and a bunch of other things, right? And this is all open source Linux code. You can go look at it if you find it interesting. Yeah, there's shared memory stuff. I'm out of time, so I'm not going to cover that. Last two slides, and then I'll open it up for questions. The whole X server runs as root. It has historically done this since 1984. We've known for over a decade it's a terrible idea. As far as I know, Xorg still doesn't offer a way to really do good privilege separation. There's been talk about this. I know some mild, super mild, very weak implementation has been done for Solaris. The OpenBSD guys did this at least 5 years ago, maybe longer. And the Xorg guys should just steal the OpenBSD code and just be done with it, right? The OpenBSD guys know how to do privilege separation. Just get their code, use it. Yeah, the other thing is that X has this thing called X-axis control extensions, which basically means for every procedure you call X, there's this thing called X-ace hooks, and you can make your own X-ace drivers, which allow you to map a security model on top of that. This is influenced by Linux security modules, and it allows drivers to implement security model. It's hideously arcane. You have to build these profiles. It's a total pain in the ass. I've been told nobody, even though the security module to do this is there, nobody actually uses this. Oh, and by the way, this is an idea from the NSA, so I don't know if I want to use this. In conclusion, how bad is it? Can we do better? Good news is I did finish the run of the client-side bugs. I'd like to believe, or I hope, the trivial bugs are gone, the client-side stuff. Feel free to go look. Maybe you'll find some more. Plenty of bugs left in the server. At least, there's got to be a couple hundred bugs left, trivial bugs left in the server, and extensions and drivers and so forth. Maybe, hopefully, when the advisory comes out for the bugs I reported 26 hours ago, maybe it'll scare people into adopting Wayland faster, and we can be done with Xorg. Yes. But even so, even if Wayland becomes this big hit, which probably will, and we'll move back to Wayland, there's going to be a bunch of legacy stuff, and Xorg is going to be around at least another decade, probably two. And so we'll have to fix these bugs too. The good thing is that if the client-side fix rate that from Alan is anything to go by, this stuff's going to get fixed February, March, if we're lucky. But even so, what we need is a driving force some way to motivate people to go in and really knock the shit out of the X server. It's long and tedious work, and it's kind of painful, but I think it's something that needs to be done. It hasn't been done for 30 years. Somebody just needs to do it. And lastly, but certainly not least, some X developer should get off their ass and just implement privilege separation. Either do it by yourself or take it from OpenBSD, but just do it. Yeah, that's more or less on time. With that, I guess I'll open it up to questions.
Excellent, thanks, Ilya. So if there is any questions, that's 4 microphones, 1, 2, 3, 4, and we might have questions from the internet too. So let's go ahead with microphone number 2 over there.
Thanks. Do you have any sense of how the quality of Wayland's code compares to the X server?
I do not. I have not looked at Wayland yet. I've seen Daniel's talk, and I've been very interested and very piqued into what Wayland does. I have not looked at their code yet. But from what I understand from their model is that it's very different. So in X, everything goes through the server, and the server is this big, massive blob of thing that has access to hardware and runs as root. From what I understand, in Wayland it's different, where the compositor owns everything, and they're just sort of this IPC mechanism. So I suspect the model is going to be better than X, and I suspect they can, if not already, can easily do privilege separation and privilege dropping. But it's all guessing. I don't know.
Cool. Thanks.
All right, microphone number 1.
Hello. I'm going to be a bit annoying to start off with by saying I do use Xlib code. I do use the Xfont server, and I do use it in network transparency mode, and it all works. We have to use it sometimes for like really low capability terminal clouds. It all still works, and I don't think you even need DRM, because like if you're using it locally,
yes,
you can use the Visa driver. But my question is, what you've said seems to imply that if you did that, if you kind of went back to the 80s and 90s and used that code, which I must admit I pretty much actually do, have you significantly lowered your attack surface? Because you make it sound like you have. Because if most of the attacks are in the extensions, you can actually run, if all you want is text on a screen, images on the screen, maybe some video, you can achieve that. You certainly don't need OpenGL. You can get rid of
agreed. No, you make a very good point. If you do that, you significantly decrease, I mean, there'll still be bugs, but it'll be like an order of magnitude less. Significantly decrease your attack surface. If you're in that position to do it, certainly on cheap terminals and that kind of stuff, you can do it. The problem is YouTube's not going to work when you do this. A whole bunch of graphics stuff isn't going to work.
I watch YouTube, and I don't use OpenGL.
And it works because I've not gone without this.
I think it uses more of the CPU. You know, if I was running
because it would never use the GPU, right?
Yeah, exactly. You're not using the
So
GPU.
all the graphics intensive stuff is going to really interfere with other things that actually want to use the CPU.
Yeah,
so depending on your trade-off, right?
Yes. Else, but yeah.
So I don't know how bad it is. I suspect because you have all these extensions with all the modern things that people do nowadays. It would have been bad. I don't know how bad it is or in what situations.
You can watch.
You might be right. I don't know.
Okay.
I just always suspected that that's the way it is. I don't know in what situations this is acceptable. But you might be right. Maybe for the average user, it would be reasonable to do it. It would certainly lower your attack surface. I agree with you.
Okay, great. That's what I'll do.
No, I think we had a question from the internet.
Yeah, Hola is asking if you encountered any significant design flaws in the Xcode that are not easily fixable by a few patches.
Design flaws in the Xcode. I mean, the protocol has some, I guess, and I said I wasn't going to talk about it, but I guess I can, since you asked, I can sort of say 2 things about it. Wow, that's a lot of slides. So, I mean, yes, I mean, there have been some X design flaws, but this isn't news. This is stuff we know. I mean, it doesn't have any kind of network encryption. So if you just use X over the network, as people used to, you have our open sniffing keylogging, and yes, you can tunnel over SSH, but it's still a shortcoming of X. So there's a set of these well-known design flaws in X. As to whether I specifically ran into design flaws in X that weren't known, no, I didn't. There was nothing there that I specifically found. There might be some, but I didn't run into any. I hope that answers the question.
All right, microphone number 3, please.
What happens with QT? What's the future?
Well, your guess is as good as mine. I have no idea. Are you talking in reference to the bugs I reported, or more general?
No, they reference the bugs. Which
I don't know. I reported the bugs. They basically said they weren't security bugs. They said I could talk about it publicly. That's all I know. I hope they will fix the bugs. Whether or not they agree it's a security bug, if you just get a bug fixed, that's good enough. If it happens to be that it's better for security, so be it. So I hope they're still going to fix it, but I have no idea.
Now, did we have another question from the internet?
Yes. Someone is asking if you're planning on looking into desktop environments.
Well, maybe. My time is limited, and there's so much X server stuff I still have to finish. I'll put it at the bottom of my list, and maybe 10 or 20 years from now I'll get to it.
Now, with that, can I please ask you to actually provide feedback for this talk, as with all the other talks you visited? You find it in the file plan. There's a little link, because I'm sure Ilya would appreciate it. I certainly found the talk very informative and entertaining as usual. So another round of applause for Ilya. Thank you very much.